Recursion equations are really important because they don't use formulas or calculus to understand things. You look at what is there and you look at what additions are there. So you can ask yourself these kind of questions even, about weight gain or loss. If someone is gaining or losing weight, for example, if they're eating more, then each day you would expect them to have this much more weight gain based off of what they're eating. And so you could say, in this year I should see this. And this year I should see this based on what they were last year. You would just add on if they were, let's say, eating more, for example. So you would just add the pieces, and that's called a recursion equation because you're taking what was there already and doing something new to it. And so they have an abstract looking what we call a difference equation or recursion equation, where the new is dependent on something of the old. And in West Point, we used to write it like this: a of n plus 1 instead of a little subscript. Students seem to understand that better, that you're plugging things in. So you can write it like this if it makes more sense to you this way. The idea is that they want you to put the first 6 terms. You start out with n equals 1 because the information they gave you was with n equals 1. See, the little subscript is 1. That's where you start. So that's your first n value that you start with. And this is new stuff that you might not have seen before. You might have seen it before in ecology. I'm going to talk to the ecology professor and ask them how they presented it. So I match up. So you probably have seen it before there. So if I plug in n equals 1, I would get into this recursion formula, I would get 1 plus 1 inside here, and I would get a of 1 here, and I would get a 1 down below. So that's what this stuff is right here. I just plugged in n equals 1 into here. Well, a at 1 was given to me. It's circled there. It's 8. And so I get a at 2 is 8. And so I get the next step, a at 2. Then to get the next one, I do the same thing. I plug in n equals 2. And if I plug in n equals 2 into this formula, I get 2 plus 1, which is 3 inside here. A at 2 is over on this side, which I know. What is a at 2 already? It's 8. I plug in 8 divided by 2, and I get 4. So a at 3 is 4. You guys are zoning with your eyes open. I've seen you do it in other classes. Now you're doing it in mine.
Why is it the same number?
Huh?
A1 was 8, A2 is 8.
It just turned out to be that. Yeah, I actually thought I made an error at first, but it just turned out to be that, right? I didn't do anything wrong with my math, right? 8 divided by 1 is 8. Easy math. So far, so good? So we had a thumbs up, thumbs down. We'll do polls next time, but we're okay? All right, this is new stuff. That's why I'm going a little slower. Okay, n equals 3. Do it again. N equals 3, plug it in. What do I get in the inside? Right here, I get 4, a at 4 on the inside. Everybody back row with me? Are you guys with me? Kind of? Okay. You know, these numbers are going to change, but see where the red is? On your homework problem, that number will change. It doesn't make sense for this one, but when I do an application, it will make sense why we're doing this. This is just a formula, so it doesn't make as much sense right now. But this is the methodology of what you would do recursively to get to the next step, given that formula. So you notice that at a at 3, I sub in the fact that a at 3 is 4, which I got in the previous step. I plug it in, I get 4/3. Recursion. You do it again. Recursion means do it again. So to get, I just cleaned up here. My sheet is getting messy, so I put a at 4 up at the top right there. And then to do the next step, I do it again. I go n equals 4. Plug it in. And if I plug it in, I get a5. a5 is 4/3 divided by 3. 4/3 divided by 3 is the same thing as 4/3 times 3 over 1. And I get 4 as a result. Right, I always have to use the next step. So let me back up here. So right here. So when I plug in n equals 3, here I get a4 on this side. But there I see a at 3. But I know the answer for a at 3. A at 3 is 4. So I plug in, instead of a at 3, I plug 4, and I get 4/3. That tells me that a at 4 is 4/3. So I have to use the previous answer to get the next one. And that's why I don't go back to the a. It's telling me to use a3, not a2, which was A2 was 8, right? I already forgot that. A2 was 8. So A3 is something different, so I have to use A3 here.
Will they ever ask us, like, it's easy to do this for the first 6 terms, will they ever ask us for like the first 36 terms or something like that? Like,
No, unless you make me really upset. Number 1 on the exam will be, do 36 terms for this by hand or forbidden to use your calculator. Unless they're being really mean, I don't think so. You can do it on Excel, like, scroll it down, so easy. So in fact, I think there might be things online. I have sheets that I developed years ago for students to do this online, but put a recursion equation into Excel, go on YouTube, and somebody will have it. It's easy to do on Excel. And you can do it on your calculators too, because I know that in Calc 2 students were doing that on the calculator. So that's where I get that from. Plug in n equals 4.
if it's like you have A of 3 over 3, right? So why is it not A of 4 over 4?
Because, it is supposed to be at 4 over 4. Mistake. Caught it. So what we do, what's nice about this, didn't I tell you? I make mistakes. I have pages and pages of mistakes in everything I do. Thanks. Okay, so that's an error. So the rest of this is an error because it depends on the previous one. And so I got an A6 that doesn't make sense. But hopefully you understand the steps, right? So the first 6 terms, I'll correct this. I'll try to go on the YouTube place and put a comment underneath it so that you know that that has an error in it. Okay, let me show you another one. Here I've plotted it, I put it as X's and Y's. It is. Usually the N stands for time and the AN stands for something you're measuring. So I've labeled it in this way. And then I've used the recursion in the same way that I did in the last problem. In this case, though, they gave me A1 and A2. You start with whatever the next number is. So n equals 2 here. So that's the first number that you plug in. You plug in n equals 1 into here, you'll get 3. A at 1 plus 1 is, you use the formula. So see, this is the formula that gives you the recursion. If you plug 1 into here, you get n equals 3. For n equals 3, you get A, 1 plus 1 is 2, 4 times A1. So that 4 times, A2 is this 1 plus 1 turned out to be A2, and 4 times A1. But A2 you know from the previous element in your chart is 2. And A1 you know is the previous element in your chart is 7. So you plug those numbers in and it gives you 30 here as a result. So far so good? I'm just plugging in the numbers from the previous information. So I just put the 30 there. I erased all the work out. That's 30. And then I do it again for 4. If I plug in n equals 2 here, I'll get A4. N equals 2 gives me A3 plus 4 times A2. A3 plus 4 times A2. A3 is 30. 4 times A2 is 8. I get 38. And I just put the 5 and the 6 there. So it's almost easier to not see it as a formula. You're just taking the previous information and plugging it into the same rule. That's what you're doing. And that's why it's easy to put this on Excel. Good? Okay, this one is also, so on this one, they have T's instead of N's, standing for time, and they give you a formula. And they want you to graph. Remember in the previous problem, I already set it up as a column for N and a column for AN. So I was setting you up. They want you to graph and look at what happens with the graph. So I put it into Excel. And again, maybe I'll make a video of how to do this on Excel. It's pretty easy. You would tell it to go back to the previous cell to do the next one, just like we're doing, automate that process. because it's the same formula that you're using to get to the next step. So Excel does that very nicely. So you make a chart of data, doing it the same way we did in the previous problem, if you want to do it by hand, or you can do it on Excel. How many of you would like to see that, a little video so that you know how to do that? I think there'll be something out there, so maybe I can just link something. But if not, like I can show you. Okay, so you like to see that. It's pretty easy to do. And then you just highlight both these columns and graph it. So tell me what's happening to the graph. Then comment on the behavior of the sequence. What's happening to this?
It's decreasing and flattening.
It's decreasing and plateauing or flattening, right? And where's it flattening at? You can look at the numbers. Calculator users, when you see 0.3333 on your calculator, what do you think it is? 1/3, right? And if they say give your answer as an exact, you put 1/3, right? And pretend like you did all the work. So it levels off around 1/3. So we also use plateaus. You also hear steady state. We also hear in chemistry equilibrium. Those are all the same. Those all have the same meaning. This is the last one, and it's the hardest one. But the question that they ask you is not any different than what I'm showing you. So what you're going to plug in, you can actually just plug in what I've shown you here today. But I'd like you to understand, because this is modeling. Modeling is actually very hard. It's not that easy for someone to just start doing. When you're creating models, you have to think a little bit and decide how to put things. So in this problem, they have fish, salmon, that they're trying to count. And the fish are swimming upstream. And along the way, they can be predated on by bears. So that's what they're trying. It's a story. So this fish can be predated on with a probability of D. What does that mean? It means as the population of fish goes up, there's a D% chance that they'll be killed off. Right? So not all of them will be killed off. A certain portion of that population will be killed off. But after they make it upstream, they can have babies. Once they have babies, all the ones that made the babies are gone, and the babies are the new population. So you're trying to recursively say in generation number n+1, how do you define that from generation n? Make sense what they want you to do? They want you to make a predictive model of what would happen in generation n+1 based on what was there already. So you're trying to count fish. You have to know what you're trying to count. So you have to figure out what makes the next generation. How do you get new fish? Where do they come from? From births, right? But they also tell you, notice that there's an M in there. The M they stock also. So once the fish swim upstream, somebody at the upstream place dumps M more fish into the pile. So there's two places that you'll get new fish, from the ones that are born and the stock of M fish. Those are the new guys. So my new guys are up there. I'm going to need some machinery to make a model, so I need to assign a variable depending on generation n. So if you have very few fish to start with, then they're not going to be able to make as many new babies, right? The more fish you have, the more babies you have. So if I let f of n be the number of fish in generation n, then some of them will get killed off. So not all f of n are going to make babies. Only a percentage of them will. What will be left? I told you, this is hard. You have to think it through. So it's going to be all the fish that were there in generation n minus the ones that got killed off. D times the amount that was totally there were the ones that were killed off. So these guys are the ones that made it upstream and can have babies. So far with me? So far with me? It's a story. Modeling's a story. Now you're going to write the recursion. If those are the guys that can have the babies, one of them can make B babies, I think they say somewhere up there. Each fish produces B offspring. If I have 10 fish, they would make B times 10 offspring. If I have this many fish, I just multiply by B to see how many offspring there are. So the next generation is going to be the babies times what was there, plus the stock. M is what they stock it with. There's my recursion.
You guys just nodding because it's almost 12 and you just want me to hurry up and finish, or you're nodding because you understand me, or you're nodding because you're falling asleep? Option 1, 2, or 3?
So that's what it looks like. They use different letters, and they didn't say what letters to use. They use different letters, but my thing is the same thing as theirs. If you factor out the f of n to the right, you see that I have exactly the same thing as them, and they are right. Good? This is really easy when someone's explaining it to you, but when you have to do it yourself, and we see it even with PhDs in math, they finish out their degree and then they're going to model something themselves. Doing it yourself is a little bit different because you have to think through what's going on. So that's why I'm explaining this to you. I want you to see it because I don't expect you to be able to do it right away, but you have to be exposed to it so you see that formula. The people I work with, they don't model themselves. They hook up with me and I do the modeling. But they have to understand something about it so they know where my logic goes. So it's a match. Okay, now they twisted it a little bit. This is one of the higher level problems. They start twisting it a little bit. They said, what if instead of them getting predated upon or getting eaten before they go and give birth, what if it's on their way back? They gave birth and then they came back, and on the way back they got eaten. So how would that change things? Well, they give birth first. All f of n made it because they didn't get eaten, right? So this is their verse. And then they got stopped, so that's what's there. These are the guys that are there. They're all swimming back. This is the group that can get eaten. Minus d times this. Make sense? Everything should make sense. When you have a good model, all of it should make sense. If someone has to ask questions about where something came from, that's not good. That's not a good sign. And if I do some factoring, it turns out that Webassign is correct. They have the same thing I have. I did a factoring by grouping, I think. I see a mess here. I see another mess here. I factored the mess to the right, or to the left, my other left. Moved it out this, and so I got this 1 minus d. And I rearranged them so that it matched. You see, it's the same thing.
If we can't get a photograph at Webassign one, we get it wrong. Will you be looking at?
This is kind of a maybe my philosophy of the Webassign thing. That is the answer. So there, when you type the answer in here, it's just looking at that answer. But I would like you to review this video so you're familiar with it. I'm going to show you a lot of cool models in here. But I wanted you to see this. I thought this problem was the most interesting. The rest of them were so boring. Laws of exponents. I probably made it as thrilling as I possibly could, but come on. I hope you don't think I'm going back to my office to hang out for a while and write down my laws a few times. So they match. So you already know it's kind of a, on this particular problem for this thing on Webassign, this is the answer because there's no red on it. So they're not going to ask you any different kind of question, right? So you can just plug in what's there. And then they ask you a question about the 2 recursions, which is going to give you more. Being predated on before they get to have babies or being predated on after. Which makes sense to you logically? What if each fish can have B offspring, and hopefully B is bigger than 1, right? Wouldn't it be better to have the babies first? So that right? So I would guess A is the right one. How do you prove that? Well, you make an inequality. I think that the left side is going to be bigger than the right, and then when you do high school freshman algebra to both sides, you do indeed see you get something like this. M is bigger than 1 minus D. But D is a probability. So this is a percent chance. 1 minus D is a fraction. So this number is smaller than this number, obviously, because I'm taking a fraction, half of it, maybe, for example. It's gotten smaller. So that's how you verify it, and that's how you answer that last question. But I don't know. They just have the buttons, I think. I don't think they make you do it. I think they just say do it. So these kind of questions people love to ask, but the truth of it is, you saw me how I developed that story. I didn't have to do this twice. I didn't make any mistakes on it.
I do this every day. And it took me a long time to get to that level. You know, something like some of the things you do every day. I'm going to see your hobbies or whatever you do every day. If you play basketball a lot, you're not going to struggle dribbling. Ever see someone dribble for the first time? Cell phones. Get cell phones out. Please put your cell phones away. If someone dribbles for the first time, they look very awkward, right? They'll sometimes double dribble. They'll sometimes walk with the ball. If you played a lot of basketball in your life, you never walk with the ball. Even if you're supposed to go from the car to you always dribble it because you're traveling. And it just feels unnatural to walk around with a basketball in your hands. So that's what I mean. Like, I've done it so many times that it's natural for me. And to get to that point is, some people maybe can do it, but I've not seen people be able to do it just out of the gun like that. So exposing you, that's what I'm doing with this last problem. Any questions?
For the quiz on Monday, we should review what we went through in the class.
The Webassign. It's been assigned to you on Webassign already.
Just the Webassign.
Right, and I went through the whole thing today. So there's a sample problem to match every one of these Webassign problems. And they're going to be on YouTube and on the playlist to look on.
All right.
So this is my number. The reason I give you my number is I'm not usually, I have to be at a desk to get an email and to answer emails. I mean, I can answer them on the phone, but it's annoying. So a text is easier. If you have a quick question, I usually can answer it. And what I'll have you do is, if you're struggling with something with, like Webassign is telling you something, take a picture of the more information you can give me, the better I can answer your question. So if you can take a picture of what you're struggling with or your work, say I've got this, but Webassign says it's this, show me your work. Take a picture of your work and send it to me as a text, and I can look at it. Right?
So on